Good evening, y'all. Welcome back to another Sunday night. We're making stuff. Making DMX-controlled stuff. We're making a DMX-controlled winch, and it's finally ready for assembly, I think. I think I have all the parts printed. I think I have all the parts... Well, I don't know if all the parts work. This will be the first time assembling them for some of them. But yeah, we're just going to see how it goes. I've already broken some things, which I think I have already fixed. When I sat down to assemble a test fit of this the first time, this, which is our barrel. I gotta come up with consistent names for these things. I've been calling this the winch barrel. Snapped in half here. I can zoom in and you'll see exactly what the problem is. We have this little neck down here that holds one of the retaining clips that keeps it inside of if bearing, and it just sheared right at that point. Right. So I've reprinted that in. That was a PLA print. This is now reprinted in this nice purple PETG. If you'll focus there, yeah. And I actually have another one of those printing just now. Just in case this one also snaps, which wouldn't entirely surprise me. So yeah, let me review with you real quick what the assembly is. Probably should have loaded this up beforehand. And I haven't really thought through order of operations for any of this, so we'll see if that becomes a problem. But we'll have our sort of working from the drive end forward. Maybe we'll apply some materials to these as we go, just to make it a little bit easier to see. We'll get out our physical materials tab in Fusion 360 here, and we'll just grab some assorted colors of plastic to slap onto things, or or resin. How about a nice black plastic? Let's see here, and here's a nice beige that we can put on. Let me put on this guy. Will you let me put on this guy? It's weird. Maybe this is. Did I import this? Is this something? Oh yeah, this isn't our imported model from something else. Okay, so working from, hey Cookie, yeah, we'll see about fire this time. We are gonna try and rev up this stepper motor by the end of the night. So yeah, so stepper motor, NEMA 17 stepper motor in the back, which has this mounting plate, which we designed last time. Some weird selection things going on with my copy of Fusion here. But that mounting plate is complete, so that is this, and that will have the same press fit sort of pin hooks that we've been using for all of the rest of our components, although they're, as we noted last time, a little bit snug because we didn't oversize this pin before using its profile to cut out of those top holes there. But that will mount to our it's topical that you're here, Cookie, 44mm truss, so that's our standard mount for that. Here, maybe we can sort of lay the parts out on the desk as we go through them in Fusion, and we'll see if we've remembered to print everything. So in front of that, right in front of that mounting plate, there will be another very similar mounting plate that's going to hold a bearing here. So that is one of something like this. So that bearing is going to be like right here. In fact, I'm not 100% sure with the hardware that I have holding this NEMA 17 stepper motor on if I have enough clearance to actually put this bearing mount here, so that might be a problem. I'm sure we can figure out a way that we slim this down. You can see I had to put a jam nut in there because my M3 screws were just a little bit too long. But I might be able to pull some hardware to slim those down. So we'll put a bearing block in there. It'll sit right in front. And that bearing block is there to support what have we been calling this? The handle wheel? Now that was our working name for it, although it doesn't have anything to do with a handle anymore. Maybe the pressure wheel? Pressure wheel seems plausible. So that is going to be... that's this guy. So this takes the place of what basically was our hand crank mechanism on the hand crank version of the winch. This is now the stepper motor powered version. You can see there's a little bit of a D shape in that hole there. And I think actually one of the things I'm going to do is just give this a real quick file out and lubricate, because part of the action of this winch, as we've looked at before, is that this needs to be able to translate forward and backward. Oh, transmission wheel is quite good, Chris. Hi, also good to see you. Yeah, is there something like transmission wheel that specifically relates to like either pressure or force, linear force? Transmission wheel is certainly better than whatever I was saying. Transmission link, maybe? So that fits just on there on that D shape, and that D-shaped hole should help that keep pretty snug on the shaft. But like I say, I'm going to put just a little bit. I was using a generic 3-in-1 oil. We'll just put a little tiny drop in there, and that's going to hopefully help our shaft just move a little bit more freely in linear space along this the interior of this part, so that as this needs to like tighten and loosen on the 3D printed threads that we'll add in a moment here, it has the possibility of doing that. Now, it of course doesn't have to move much to be able to do that, but it does have to move some. So we'll see if that actually works. Yay, Thomas! Yeah, just here for lubing. Thomas, you didn't miss anything. We have more parts to lube as we get this thing in motion. Good to see you as well on this Sunday night. All right, so that is our transmission frustrum. I'm gonna go with transmission wheel for now. That seems decent, right? And then that transmission wheel screws onto our barrel assembly here. And in between the two of them sits our ratchet wheel. That barrel sits inside of our frame. Like, this is the part where I'm like, I'm not 100% sure what order of operations is going to make sense. I think what I'm going to do is basically we've assembled this part already, right? That's essentially this. Now we sort of have to sort of do a test fit and see if this will fit in here. Maybe we can do that now. I have a handful of these additional spacers from last time. Let's sort of press these into our 608 bearings here. Oh yeah, right, these are a very tight fit. Perhaps. Oh, there we go. All right, so there's that. And that wants to sit in between these two. Ah, you know. Oh, no, I know what it is. That doesn't go there at all. So that, I was like, what? Did I make a spacer to fit on the shaft of our NEMA mount? No, that's not where that goes. So let's see if we can, now that I've gotten it in, let's see if we can get it back out without destroying anything. There we go. So this bearing actually goes on the transmission wheel, I guess we'll call it. I'm gonna give that a quick file as well. This is gonna be like the filing and lubrication stream, which I assume what you come here for on these Sunday nights more than anything else. That and like Arduino code sometimes if we're lucky. But we'll just give this a real quick file because this part also, remember, so this has to move linearly within that bearing. And as I'm doing this, I'm wondering, like, you know, in principle, right, when this is all assembled with the barrel part, which we'll simulate here, right, this moves laterally just very slightly to increase and decrease friction on the ratchet, and that's what makes the operation of that winch possible. I'm curious to see, like, once we have this all assembled out of plastic and hanging from other plastic by plastic linkages, like, is the, like, amount of flexure that we have in those in these parts going to make that, like, all of the hard work of, like, making that mechanism possible just going to be obviated by the fact that it doesn't end up being a particularly rigid setup. But we'll see. So this now should fit inside of here. So that's where our second bearing goes, is inside of that. Now, what I think I'm going to do is try and remove this without breaking the transmission cone. Chris, I don't want to say I don't like transmission wheel. I do. Wow. On the other hand, maybe this just stays on there for all time then, huh? It's gonna be a little bit of a problem when I want this to, like, slide, but maybe we can do a little retroactive lubrication down around there. We'll see if that becomes necessary. Maybe the flexure of this plastic will actually end up helping us out. Okay, so that is what will fit into our support block here, and all of that will be, where's our D shape? There we go. Yeah, so that's what that mechanism will be. Hey, that's kind of cool, right? And all of this would be hanging by its own sets of our squeeze pins, hanging off of our 44 millimeter truss, right? Okay, that's interesting. That feels, it's kind of cool to see it in this form, see it sort of slowly coming together, which I do quite like. Ah, there we go. So that's fully inserted. But I want to back that out just a little bit. But yeah, so we do still have clearance there, so that's quite good. So that's, like, sort of the, like, drive assembly side of this stuff. Turn my gain down just a little bit here. Let's assemble the other side of this mechanism. I'm trying to, like, having Fusion open is sort of helping me track through like the narrative of what's going on here, as well as like how I'm gonna actually assemble this darn thing. So that should be kind of interesting. Ooh, Cookie says, I think I might get a breakthrough on curved truss next week. Going to try arc welder. Ooh, that's fun. That's super fun. Yeah, I want to hear how that goes. That sounds awesome. What size? You're over here. What size are you thinking, Cookie? Like, what's the like diameter and chord spacing and all that on that guy? Let's see here. So let's get our. This is our barrel, our ratchet. I can deal with the ratchet wheel and like the washers that go on either side of it last. So it's really the barrel, these two arms, the frame, and the bearing have to all happen sort of simultaneously. I'm going to zoom way out for now because I'm not quite sure how to capture this in a way that will be visible. So there's our new lovely purple PETG barrel, right? So that's the part that interfaces with our friction setup, our threads that interface with the thrust cone, transmission cone, transmission linkage, says Chris. Not bad. So there's that. So let's get this mounted in a frame. Now I did finally print out the version of the frame that has the pin clamp mounting points. So that should be functional. Let's grab here. I'm going to see if I can reuse. Yeah, I had an old test block for these bearings. And I have more of these bearings, but I feel like, you know, there's no point in them sitting inside of these, in the other unused parts for ages. Okay, he says, outer diameter 350 millimeters broken into 4 small prints on the mini clutch brake. Ooh. Yes, now Jeff's going to make some linkages to make the kabuki drop around a corner. That would be cool. You know, I think, basically, I didn't even bother to set up my camera that points at the micro, the micro stage? Is that what we've been calling it? I'm a little bit out of it tonight, as I think I am every week. But let's see if I can get, there we go. Let's see if this camera will just start up here. If I plonk it over on the thing by the micro stage. And I'll point a little light at it. In theory, if by the marvels of technology, hey, look at that! It just works. It's a little bit cropped, which is weird. But yeah, given our mechanism for the kabuki that we came up with, I think that the trick would be, like, the supports would basically work, the hooks would basically work, the challenge would be, right, like, how do you, what's the curved pipe? Like, is it like, the thing that comes to mind for me is like, something like a plumber's snake, right? Where you have some kind of like semi-rigid piping that like flexes but also like transmits rotational motion. Like it can't be anything that it has to be able to transmit the rotation of the pipe itself around a corner, which would be kind of cool. I'm noticing I'm glowing tonight. I'm really just radiant, and maybe not in a good way. So maybe I will just, for the sake of vanity, just turn my gain down on my face a little bit here. Now, if I could figure out which one that is. That is face. The camera labeled face is in fact my face here. You get to see my vanity process. As my forehead increases in size, I find I care more and more about the lighting on it. So let's see here. Let's just turn the gain just down a hair. There we go. That's a little bit nicer. A little bit less reflection into your eyes. All right, that's pure vanity though. We'll get back to the assembly here. So let's see. So we have our frame, we have our barrel, we have our ratchet parts. I'm gonna just get this drive pipe out of the way here for a second. So this is the thing that we had screwed up last week, in which I had to remake. You remember the original form factor of this barrel was this, right? So this is the linkage that goes into the flattened end of that, of this. I just need to standardize on names. Like, this is the end of our pipe that'll actually rotate and drive the winch shaft. that we sort of sanded. I have sanded down to fit into this hole, and then I made a nice like alveolar pill-shaped linkage so we could put these heat set inserts into it, so we could put grub screws in, and that would lock the shaft in place. And then unfortunately, I realized that that shape cannot fit through this bearing, right? That doesn't work. So basically, I just cut the bearing size, the hole size down so that it does indeed fit through that bearing. Or at least in theory. This is a fresh off the print part, so we might have to do a little bit of sanding here. Yeah, it feels like we will. This is also the first time I printed this part in PETG, so the tolerancing may be just slightly different than when it was in PLA, and we had dialed that in fairly precisely, so I'm not actually 100% surprised this is a little bit snug. Just the way that like PETG expands slightly differently than PLA, has slightly different artifacting on the corners, so like a part printed in PLA versus a part printed in PETG are going to be just slightly dimensionally different, even though the printer is quite well calibrated and quite well manufactured, like they're never going to be exactly the same. And that feels a little better. Just a little bit of filing there brings that into the shape we want it to be. And I can feel I'm going to have to do a little bit more because the part that I have filed is quite good. That slipped through quite nicely, but of course the bearing wants to end up right about here. So we'll do a little bit more filing just on this middle section here so we can get this all the way into the bearing. Make sure we can clear that gap. If you're going to have like shoulders and artifacts, it's often going to be around changes in dimensionality. So as I was pushing this in, I felt I got to about here, and then clearly there's a little tiny. I can just feel it. I don't know if you can see it, but there's a slight out bulge here, just based on like the fact that it was printing what I guess was a ceiling and a floor at this level, and like even that few thou of change in diameter is enough to be able to prevent it from going smoothly through the bearing. But a little bit of filing hopefully will take care of that. Let's give that another test fit. That's quite good. We'll just do this gently so as we don't snap it off. Yeah, so got another little snag there. Let's see if we can get that back out. It feels like it's snagging, somewhere where this hole is inside of the bearing surface. So I'm just going to give a really good file to that area. Because that's also, because that's a fairly thin wall, I wouldn't be surprised if that had some dimensional changes from the optimal, if you will. Let's get that bearing back in place, and now let's see. Yeah, there we go. Oop. Can I go all the way in? Yeah, there we go. Actually, a little bit too far. Just gonna press this back down. Actually, I might have to press it all the way out to get that bearing back where I want it. Oop, yeah, so I thought that might happen. So that's pressed all the way out. Now we'll just take a couple of our files, sort of crosswise underneath that part and press it down. Yeah, that's pretty good. So that's where that bearing wants to sit on that part, and we'll trap it in there with a couple of retaining pins once we have it exactly where we want it. I'll probably just steal those off of older Winch prototypes. All right, so now that that's in, we'll put the bearing back into the winch housing. All right, this is where things start to get a little finicky. All right, let's see if we can I'm gonna zoom back out again so I'm not flailing out of camera all the time. All right, there we go. So that's now the barrel sitting inside the housing, spinning well. All right, it's a good sign. Now, I do need to do a little bit of cleanup on this winch housing here. You can see I've got a little bit of spoilage up there. Now, it should be all right because I left a ton of clearance for the Ratchet poles, so that, like, if this surface ended up super rough, which it obviously did, I should still have plenty of clearance. But, of course, because those poles are going to be under quite a bit of force from the springs that are pulling them together and trying to get them to engage with this ratchet wheel, I should make sure that those are, at least decently smooth. When we do here, let's see, we can probably just test fit this in in place. This is obviously not the final orientation of this, but that's already moving quite well, thanks to that extra tolerancing. So I'm not too worried about making these pristine. I find you can probably tell from the style of that that spoilage there that I printed these. This was not a supported section. This was just it was printed in this orientation, and so this was a ceiling, and so we just get that classic like spaghettification of things drooping down from the first ceiling layer, and that actually proved to be in my test prints easier to clean up. And a better surface finish when everything was said and done than doing it with a small number of supports in between those two sections. Originally, I was like, oh, I'll do like a half an inch of supports just in the middle of this part, and the resulting surface finish was so rough I couldn't actually do anything with it. Okay, so that winch arm fits as well. Let's see here. Maybe we should try and get these winch arms in place before we do anything else. So you'll recall that these fit around, let's see, around the ratchet wheel in a frankly too convoluted setup. Let's see here. See if we can trying to get like each ratchet arm to go through the hole in the opposite ratchet arm at the same time is tricky, but there's nowhere you can actually like hold the thing so that you can actually see them both at the same time. I'm just gonna just to make my life a little bit easier. Let's loosen the tolerances here as well. It's not extraneous filing. It's giving yourself additional tolerance, and tolerance is important. All right, let's file that hole out a little bit. And oops, now I've gotten this stuck. There we go. I'll file this hole out a little bit. We'll probably lubricate these as well. Filing a lubrication stream. Okay, get that nicely cleaned out. Anyway, let's see. So let's make sure these actually do fit through each other before I try to do this in situ, as it were. So yeah, so that's the ultimate configuration they want to be in there. Right, but they want to do this, but the barrel protrudes through this part, which makes it tricky. So let's try again. So we'll get one over the top. We'll get the other sort of underneath the barrel, and then we'll just play wiggledy until we can get them both lined up. Now that is good. See, this is the thing. It's good that I get one of them. What I really should have done, he said, in perfect hindsight, was just make. So like one of my goals was to make these two arms identical, right? They're literally the same print twice, which one of them is oriented 180 degrees to the way the other one is, and I was like, I was pretty proud of myself. That worked out pretty well. But what I should have done is make one of them like 5 millimeters longer, so that it would engage its hole first, and then I could turn it around and have the other one engage the other hole second, rather than what's happening right now, which is that I literally have to get them both, because they're identical parts, they have to engage at exactly the same time, or like this one is engaged, that one is not, and to get it engaged, I have to undo the first one. It's kind of like one of those like mechanical, hey, there we go. It was like it feels like a mechanical puzzle where the ring has to pass through the rope, but the rope is not a ring or something. All right, so we'll put our first rubber friction washer on. I'm going to remember which way this ratchet wheel goes. Must be this way. And then we'll just try and get this inserted without disturbing those ratchet pawls. Let's get this out of the way here. There we go. Well, I've not successfully done that. I've definitely interrupted those ratcheting pawls, but the ratchet wheel is in place. I was scared there for a second that it was going to start hitting the arms, these red support arms here. So I should probably go back and give those a little bit more tolerance, not with a file, but like in the actual 3D print. Although now that I'm looking at it, this might be easier to do now with the ratchet wheel in place, because the ratchet wheel is kind of holding the pawls in a bit of an orientation, or at least holding one of them while I insert the second one around it. Now, I say that immediately before trying it and realizing it's not that much simpler. There we go. Okay. Yeah, so now we can see that, you can kind of see on the side that there's blue ratcheting pawls engaging that blue ratchet wheel, just a little bit there. Maybe I'll make it a little bit brighter on that camera. I think that's a thing we can do. Yeah, just so we can see that a little bit better. I realize I printed this in various parts, but some of the parts that interface mechanically are the same color, which must be a little bit hard to see. And we'll just move this barrel outward just a hair in this bearing if we can. Get it. Oops, I've slipped that bearing in the frame, which is not what I wanted to do. Oh, and I've lost the pawl again. This is what I was saying about this being a finicky process. Once we have the what was I saying? Once we have the springs in place, which maybe we should do next, that should help hold the ratcheting pawls in place. Chris says, make them have a breakaway extension on the ratcheting pawls, presumably print them both, and then cut one section off, and then assemble. Ooh, Chris, I like it. You can tell Chris has made and assembled many a one-off thing in his time by that kind of session. Yeah, so we'd make them both extra long and just snip one of them short, and then they can continue to be the same length, but at assembly time, they can be unique. That's great. And I do remember we had some issues assembling these last time with these springs slipping off. And let's see if we can do some spring crime to get these to actually stay this time. That seems all right. You stay there. And this was the major innovation from last time, was including this hole in the bottom of the frame so that we could actually get at this lower spring, which I didn't do the first time, and it was for those who were here, remember, it was a horrible nightmare. Hi, Mom! Good to see you. There, give me 1 second here. Oh gosh. Just double check a couple of things on the micro stage camera, aka my phone. Oh, let's see here. Don't crash on me now, micro stage camera. Dave, good to see you. A pleasure. Sorry, you're just staring at I'm a little afraid to touch this now. Now that I've got it actually, like semi-assembled. But, oh no, I have indeed crashed the micro stage. Now I was hoping I could show this in relation to like where it was going to orient on the micro stage, but I seem to have crashed the Epoch Cam app, as well as maybe other things. Oh gosh. Yeah, oh, you know what it is? You know what I bet it is? It's very confused because I like locked it in an orientation, and now well, we'll just turn this off for now. We'll get back to doing something interesting, but suffice to say, maybe we'll give that a second to power off and reboot, and we'll keep assembling this thing. So let's see here. Let's see if we can get this spring assembled into the winch here. Oh no, I can actually knock them both out here. I think we maybe also concluded last time that one spring was going to be sufficient. So maybe if I can get this assembled again, we'll leave it at one spring for now, just for the sake of continuing with this assembly process. Let's see here. So zoom myself out again. I'm torn between like trying to keep it zoomed in, but I realize like I'm awful at trying to keep the tiny zoomed in things visible to y'all, which is the whole point of the thing. All right, so there's our winch ascent. Oh no! Spoke too soon. All right, so in terms of like the fiddliness factor, this part of the mechanism is less than ideal, clearly, but for those, I don't know how many people like read the spring has sprung, says Chris. Yeah, exactly. I don't know how many people like actually are like, I see Jeff's doing XYZ tonight. I shall join for that. Or people are just like, I'll just drop in. But as I think I put in the description of tonight's project, it's like, this is the first assembly of all these parts, and I'm excited about it. But I can't imagine it will be the final assembly of all these parts. So this will be high on the list of things to de-fiddleify, if you will. All right, let's see if we can get this one spring back on here for now. There we go. Okay, so that's back in place. So now we are, I think, basically ready to marry our two subcomponents together. And I think part of the question is going to be like, what is the size of friction washer that we need between those two components? I guess properly, this is their final orientation, because that's where the pin clamps go. And thankfully, it looks like they're all mostly aligning. Seems to me, oh yeah, so like the plane, at the top plane of these two where the pins go, and this plane should be equal to each other, because of course it's all these same pins. So I'm going to assemble it like this, but no, in its final orientation, everything will sort of be hanging upside down from a piece of trups like this. So I think let's start with our, that's going to be a little bit too big. A little bit too small. Let me pull out my big crate-o winch stuff and see if there are alternative friction washer options. Because I don't think we want to thread this too far down onto the threads here if we can help it. We might have to trim one of these down a bit. That might be okay. So now let's see here. So let's screw that in if we can. yeah, it's coming together. Okay, so. There's a fair, so partly because the tolerancing is weird, and partly, partly because I have parts in PETG and PLA. Oh, at least the pawl stay together. That's good. The screw thread parts are like a little bit more of a tight squeeze than I would ideally like. And I'm a little wary about filing them because I'm worried I'm just going to shave the corners off of what is ultimately what is a screw thread, and then will be kind of hosed because we won't screw together at all. It's also partly why I'm printing a second one of these purple barrel assemblies now. So if we do really trash it, we'll have another one waiting for us in about 45 minutes. Okay, so let's get that. This is, I could have just titled this stream trying to get two ratcheting pawls to engage with each other. The stream. Live. It's also just not, as I'm looking at, there's not a lot of, once they are engaged, there's only maybe, 3 millimeters of travel with them in their sockets before they start engaging the ratchet wheel, and there's just no need for it to be tolerance that closely. Now, it would also help if I put the ratchet wheel in the correct orientation, I suppose, if we're being really picky about this stuff. Let's see here. Okay, so there's that. And once again, we'll thread. Maybe we'll do one more dab of 3-in-1 oil is the word I was looking for, just on the inside of our threads here, so that this can move nice and smoothly. And we'll just thread that in a little bit, and then tighten down. I gotta put this spring back on, nice and gentle like. See if we can get that spring to stay on these slightly deteriorated hooks here. We'll go the other way. No, we won't certainly go the other way. That's not going to do the thing. All right. So there we go. All right, so that's now got friction. Well, let's realign these puppies. So that, wow, is our winch assembly. It's wild to see it sort of start to coming together after all these weeks. Yeah, that's pretty cool. So the principle here, right, is the same as it has always been. When the friction frustrum spins clockwise, it tightens its grip on this friction washer. And when that friction becomes sufficient, it will start to rotate the ratchet wheel. And when it does that, it will cause the arbor on the other side of this to spin, lifting a load that is attached to it. I'm just rotating this by hand for now. And when there is a counter-rotating force on this, when the servo spins slightly the other direction, we will loosen the friction on the ratcheting wheel, and that will allow the arbor to slip a little bit on the friction. That will allow things to lower, but by lowering, those screw threads that are in here will tighten and prevent it from lowering any further. So when there's no force applied to the servo, things are static on their own. It's a static mechanism. But when force is applied in either direction, we will either lift or lower our object on this winch as long as there is some force acting on it. That's the theory anyway. That's the principle of the thing. I'm excited to see if it works. Let's see. So we have this this arbor here, which will be is sized to be full size for the micro stage, which is exciting. It makes it a little bit impractical to test with, and also because I decided in all my wisdom that this should be a slotted hole. It's a little bit of a pain to file or to sand down, grind down the end of an arbor to fit it, especially with a little benchtop Dremel. But that is it inserted and assembled. Yeah, Chris, clearly, I think the thing I'm working against most in this orientation is just the friction of these threads on the friction wheel and the barrel. The ratchet is fairly strong, but it's not, I don't think it's overwhelming. I think mostly we're working against the friction of the threads here, which is something I could probably work on. Okay, well, to test this, we'll need a few more things. We will need, so I'm going to use this. I printed, you remember we designed a few of these lifting barrels. These ones actually still have their support material on them from the 3D printers. Maybe I'll rip that off real quick. I can show you what these were supposed to look like. And then actually we're going to use one of the misprints from last week's like 1 hour dip in, dip out, barrel extravaganza, because the way that I goofed it up in the slicer is actually going to be really useful for our testing purposes. But let me show you what these were supposed to be first. Some support material off here. What I probably should have done, and it did a decent job. Being a lot more specific with where my supports go on most of these prints, just so that like they're not leaving any additional like rough surfaces where I don't want them. But these were a couple like quickie things that I threw on the printer this afternoon, and I didn't really care too much. Chris says thread spools. Yeah, that's all this design is, right? It's like a thread spool with a hole that is, intended to fit a 3/16 shaft. Not even gonna bother to clean it up too much, but yeah, it's a spool, the hole down the middle. It's got a hole in the side to accept a one of those heat set inserts so it doesn't slip on the shaft. Which we'll probably find is a thing that we need to do. So that's what the design is supposed to be. When I sliced it last time, I accidentally like intersected it with another one of our like little spacers here. But that's actually a really convenient place just to tie a piece of string to test this with. So I think that will end up having been a happy little accident in all of these things. So let us get that in place. So I'm going to take one of the end supports off. Oh no! Should have been more careful. I've snapped my barrel in half. That's a bummer. but maybe not an insuperable bummer, because since this is a D-shaped hole, for one thing, we have another one of these printing that is 64% of the way done already. And it's going to take us a little bit of while to set up like the servo motor code and wiring for this again anyway. It does mean we'll have to redo some of those ratcheting pawls, which is only a little bit of a shame. But we can figure out the rest of this as we go. So lesson learned, it should be a little bit more gentle with that part as we go. But what I'll do here is just thread one of our spools on here, and we will put our block supports back on. So this will be the ultimate configurations. We'll just have this here, and then we'll tie a piece of string around here, and I'll probably hang a weight off the edge of my workbench just to provide it, because this mechanism needs some counterforce to be able to actually lower the weight, right? If there's no, much like, I mean, it is the exact same mechanism as a classical chain winch. It needs a downward force to actually pull the chain out. Here, why don't you all look at the table for a sec, and as I avoid tummy cam, and I will grab a little bit of line or wire or something to serve as our lift line. Oh, this might do. Got a little bit of like really thin gauge picture wire, which is obviously not the final solution because it's not going to bend around a lifting bobbin super well, but it is going to be really easy to apply and to work with. So I'll just use a little bit of that. So a little bit of a setback with, me breaking that, but like I say, this is why I was like, maybe we should have 2 of those. That seems like a critical part for tonight. Almost anything else we could fudge or make up, but that one would be hard, and so we have another one of those coming. So I'm just gonna thread this little wire here through the post that we accidentally made in our bobbin, and we'll just twist that to stay. We won't even do like a fancy knot or anything. Maybe we'll just tuck it through itself just to help it to stay. All right, so now as this rotates, that will wind itself up a little bit. And then we're not going to wind very far, right? We're going to sort of test to see if this works. And we're not going to like haul this thing up and down. I think it's gonna that'll be for test night 2. But now I'm sure you can't really, you can't even see it at all. But off the edge of my workbench here, down by my shorts, down by my legs, which you so rarely see, I'm going to hang some kind of a weight off of there, just up something easy. Maybe, what I've been using as a weight for a lot of this, if I can spot them, is a pair of vice grips, because it's really easy to clamp them onto a line to have them test a thing. Now, where, if I be in the vice grips container. So it's going to take a pair of vice grips, and now off camera, just hang them off here. That actually might not be enough weight to get this thing to move, as I feel how much friction is in that thing. And I think where I have this placed on my desk, it's not just going to go dragging the whole thing off the table, but that's also a little bit of a possibility at some point. Probably bring more All right, so definitely a possibility at some point. All right, well, that's less than ideal. Let's use our favorite adhesive, sticky tack. As long as I can prevent this from sliding on the workbench, I think that's going to be sufficient for our purposes this evening. So we'll just do add a little friction here. I know I've mentioned it before, but I love sticky tack as a prototyping mechanism, because it's so easy to work with. It lasts a while. It doesn't leave much residue. Like, it's, for this kind of I just need to try a thing. Blue tack, sticky tack, teacher's putty, whatever you want to call it, is really a great material. So let me see, just because I will want to see if I can orient this in space. I'm just going to turn my phone back on and see if we can get FBot Cam to once again behave. Here. Let's see, what do we do next? Well, while that other barrel is still printing, let's get the electronics set up here on the table. So we have our our stepper motor driver board's still kind of set up from the last time we were messing around with it. So we'll plug that back in here. We'll have to redo some of the Arduino experimentation we were doing, but that's fine. That would be a nice refresher anyway. Let's clear this out a little bit. We'll clear out the bubble water. It's very tasty. This is actually not a standard bubble water. This is a city water hard seltzer from our friends at a place that is tasty and delicious. From City Seltzer Water. Go figure. Based out in Naperville. Hard seltzer water, very tasty. All right, well that's all the connection that goes into the servo motor. Let's pull out an Arduino Uno and get that wired in. Oh, maybe I did the prototype with a Pro Mini? Either way, I seem to have sorted them back into stock since the last time we did this experiment, which was pretty silly. So once again, enjoy the table as I go grab the bin o Arduinos and stuff. Here's the bin o Arduinos and stuff. Oh, I do have, oh no, I was gonna say that's an Uno, but no, that's an Ethernet shield. Oh, let's do a Mega. That's easy. Just for like plugging some things in and getting them working, I think that'll be sufficient, unless we want to, well, it's fine. It's fine. We're making this up as we go. It'll be fine. Oh yeah, Chris, that's a cool idea. Put it on a pegboard option instead of hooks. We could like lock it down to the table when we're testing things. That's a neat idea. So let's load up. I can't remember if we did this in the Arduino IDE or in Visual Studio. I think it was in Visual Studio that we did this, but I might be wrong. Either way, let's go find, literally, let's go find where we put that code last time. DMX AF motor demo? AF motor demo. Excel stepper. That feels right. Sign ring out library stepper test. That sounds like a thing we might have done. We like tests, and it did involve steppers. Let's see here. Steppertest.ino. Excel stepper. Can you see that all right? Yeah, seems all right. Wait between steps per rotation. Yeah, so this has moved very slowly back and forth. So let's make sure we get our pinage correct here. So our step pin was connected to Arduino pin 2. So let's see here. I'm going to attach a few things. We're also going to need to hook power and such back into this. Okay, so we can zoom in just a wee bit. This thing needs... All right, so that is our ground pin. We'll attach that to any of our ground pins. We need a 5-volt supply pin. I'm going to need one more pin-to-pin jumper. Do 5 volts to the driver board to power its electronics. So we'll plug that into the 5-volt pin on our Mega. Then we'll need a V-in and ground. I think last time we did this with the bench power supply, which I think I would do again. So we'll get that hooked up in a second here. And then we have enable, which if memory serves was active low. So we'll plug that into ground. We had our direction pin, which according to our sketch is pin 3. And our step pin, which is pin 2. And we'll hook that up to our power supply in a sec. And of course, we'll need to plug this all into a USB A to B cable, which I have on the bench here. And we'll give this a quick test. Now, maybe when we test it the first time, we shouldn't have the whole thing connected together. So maybe we'll pull the, what's the best way to separate these? I was gonna say maybe pull the stepper out, but I think it's gonna be a little bit tight. I don't really want to undo this though. You know what we could do to test this code is to just grab another stepper motor. And we'll test it first, and then we'll test it with the one that's actually plugged into things. That seems like a smarter choice. Let's get a little bit of... Oh, hey, there's the tum. For those of you who were... whoever had the pool on tummy cam at less than 50 minutes has won. You can pick up your winnings at the door. talk to Sven. So there's a secondary stepper motor, which they'll put a little piece of blue tape on it so we can see when it actually spins. Let's see. We'll get our power supply hooked up here. Ooh, I've made a bit of a mess of these cables. That's all right, because the two that we want are still attached. Those cables are there, by the way. I should say I had a very exciting time. I went to I think I might have mentioned last week, we went to a ham radio swap meet way out in the deep burbs, which was outdoors and kind of a perfect event for right now. And found a thing I've been looking for ages, which is a benchtop multimeter, which, if Etbot Cam still worked, which maybe it will, I can possibly show you wirelessly. Wow, that would be the future, huh? Well, I mean, I know looking at my phone is not the scintillating content that anybody wants, but let's see if this just works. If I do that, I mean, it's not great, but it does kind of work if a little bit jerky here. Maybe I can prop it up here on the top of this monitor. So yes, this is a Fluke 8012A digital multimeter benchtop meter. It's, I mean, at least 10 years old. But I got it for $5 at a swap meet, and it works pretty well. There's volts, milliamps, resistance, and it has a low impedance mode, so it's got a 2 ohm scale and a 20 ohm scale. And the nice thing about having a benchtop meter like this is literally just that it doesn't walk away, right? Like my other multimeter that you've seen me pull out a bunch, that big green handheld one, always is wandering around. I take it down to measure something in the rest of the house, or borrow it for a gig. This one's not going anywhere. So I'm excited to have it. It also measures susceptance directly. You can see that S equals 1 over omega button. So you can actually measure a susceptance, which is the inverse of impedance, or the inverse of resistance directly, which is a funky thing for a meter to have that I kind of like. But anyway, yeah, well, let's see. It just has all the things that were crashing, stopped crashing. I think so. I think they have. All right, well, that's great. Well, we'll get that stuff later if we need to take a look at the micro stage. But that's kind of a cool option to be able to be like, hey, here's a... I feel like I'm always like, hey, guys, hey, folks, here's a random thing on my workbench. Wish I could show you. Now it's like not a great picture quality or frame rate, but at least you can be like, hey, look at this cool thing. Anyway, where were we? Oh, stepper motor. That's right. Hooking up power supply to stepper motor. Stepper motor is plugged into power supply. Table is visible. Power supply is on. Maybe let's upload some code here before we turn the power supply to anything above 0 volts. So in VS Code here, I probably need to do change board type to Arduino Mega. Let's check our serial port, COM4, it seems to be. I do not want to take a quick survey about VS Code. I would like to upload. And if all goes well, that should just work. We're verifying, we are uploading, and we're uploaded. Okay, so now, if we were to turn up our voltage to something operational, like 12 volts or so, I did see this move at one point, I feel like. So it is, I can feel it moving, I can hear it moving, unless I'm hearing, well, I'm partly hearing the 3D printer stepper motor behind me. This is a little bit weirdly static. Let's see, maybe let's increase the, we had our microstep set down to 30 seconds of a microstep, and I've also lost my power here. Plug that back in. So let's see, now we're really flying. Get out of there, hey, let's move over here, okay. So, seems like, when the microsteps get too small, we discovered that there was a rate limit to them, I think. So maybe we need to just increase our time between steps here, just briefly. So we were at 8 milliseconds between microsteps. Now we're at 20 milliseconds between microsteps. So hopefully that'll be a little bit better. Let's really slow this down. I'm going to go over here just to 50 milliseconds between microsteps, and we'll see if we can keep this just a little bit smoother. There we go. Yeah, full microstepping at 1 rotation, a little bit slower. Okay, so that's a decent rate. Maybe we'll even go half that speed, and we'll double. We'll do like 3 rotations. Let's do like, I don't know, 10. I mean, you can't see anything. I'm over here. We'll do 10 rotations in each direction at half this speed. Let's upload that real quick. See what happens. Turn my voltage down just a little bit here. Well, now it's not doing anything. Oh, you know what I think has happened? We have an overflow error. I used an integer to track the number of steps per rotation, and I'll bet I overflowed. I'll bet 10 times 32 times 200 is more than 32,000. Yeah, that makes sense, because 32 times 100 times 10 would be more than 32,000. Now, still nothing. But also, we should use long integers in our loops, so that our comparison is valid, and we can probably speed that back up just a little bit. Okay, re-uploading. We'll see how we do. Verifying. Uploading. Done. No, something is still wrong. Let's see. When I increase the number of steps per loop, is when things got screwy. So let's decrease that again, and we'll work back up to something that works. We'll go back to a known good configuration. Yes, okay, so that has the stepper moving. So it was when we changed this step here, steps per rotation equals 200 times 32. Wonder if it's truncating it. Here, let's see if we can find a thing that reintroduces this error. So let's multiply this times 5 and re-upload. Now we're into the troubleshooting part of the night, which is a part I like. You tell me you like it too, so hopefully this will be educational. I'll try and explain what the hell is happening as we go. Okay, so this now should be doing 5 rotations in each direction before reversing, or roughly 5, because it could be skipping steps without us seeing it. So let's try. We knew with 10 things broke, right? Let's see here. So let's come back. We'll re-upload. Verifying. We're re-uploading. And now we're stationary. So what I think is probably happening here, and this is just a hunch, is that we're computing this. So this is telling me, like, this is by default, this number 200 is a 32-bit integer, 16-bit integer. This is a 16-bit integer. This is a 16-bit integer. We're computing the product of those 3 as a 16-bit integer, and then it gets truncated because this is too big to hold in a 16-bit integer. And then we just happen to be storing that language in a long integer, or that number in a long integer. So I wonder what happens if I precast one of them as the long integer 200. Oops. Well, it throws an error. Primary expression is specified for long. Let's see. Let's do this in a slightly different way then. Let's say the number of steps per rotation is 200 200 full steps per rotation times 32 microsteps per step. And then we'll say long total steps equals 10 times steps per rotation. And we'll make that the total steps variable, we'll make that the index of our loop. Steps per rotation becomes total step, steps per rotation becomes total step. Let's upload that. We are uploading. Yeah, there we go. Very cool. Okay, so that's kind of an interesting error, right? So just to recap what happened there, we have this value steps per rotation, right? Our original code was just to spin 360 degrees in one direction, then reverse and go 360 degrees in the other direction. And because we have lots and lots of tiny little microsteps per per rotation. This was the calculation of how many steps was 360 degrees. And it's 200 steps, 200 full steps normally. And we have it in the mode where we do 32 microsteps per step, right? So when we were running with this code, we were doing whatever that is, 32 times 200 is like 6,400 microsteps per rotation, right? But when we tried to say, okay, well, instead of doing one rotation, I'd like to, in fact, do 10 rotations every time I run through this loop. So we just started by changing our code to just multiply that number by 10, and that didn't run. And why not? Well, 10 times 32 times 200 is what? He said, reaching for his off-screen calculator. 10 times 32 times 200 is 64,000, right? That makes sense. 64,000 is larger than the largest number you can store in the basic integer. In Arduino language, integer means 16-bit integer. You can see VS Code here is suggesting alternate, more specific data types. Arduino is like, it's an integer, but if you were writing in like C or C++, you'd often say int 16, int 32, int 64, and actually specify how many bits you want to store this as. So we were having a truncation issue where we were creating this number 64,000 and trying to store it in a variable type that only stores numbers up to 32,000, right? So I was like, okay, well, that's an easy problem to solve. We'll just use a long integer, a 32-bit integer. That can store numbers up to 4 billion, right? That should be plenty. And that still didn't work. And what I believe was happening is, and this fix confirms my thinking, I think, is that rather than saying, okay, we'll calculate this large number, 64,000, and store it in our long type integer, we were taking a 16-bit number, multiplying it by another 16-bit number, multiplying it by another 16-bit number. And when we were doing this multiplication, it was all assumed to be in 16-bit storage, right? So we were still getting that truncation of our math here before we ever tried to store that data anywhere that could hold a large enough number. So by breaking this, and there's certainly many ways you could solve that problem, but one way that sort of makes things a little bit clearer is we'll do this multiplication in two different steps, right? So we'll say steps per rotation is 200 times 32 like before. We'll store that as a 32-bit number. So when we multiply it by 10 to get our total steps per run or per direction, say, we already have this value stored in a 64-bit number or a 32-bit number. So we have lots and lots of room to store the results of this multiplication. We're not going to get it truncated to 16 bits prematurely. And so by running that, we're getting our full 10 rotations per cycle, and then it should reverse and go the other way. So that's quite exciting. That's also getting a little bit warm. Not worryingly so, but a little bit warm. Dave, no, in answer to your question, there are no short stories. There are only short fires. So before we go ahead and hook this up to the system here, let me just take a little peek. Our next barrel is at 84% printing. This is going to time out so well. What I'm going to do, I think, is give myself slightly finer control over this. I'm going to turn my stepper power supply off for a second here. I'm just going to hook up a couple of buttons to our Arduino, just so that rather than having it run an automated program, we can like press a button to drive forward and reverse. I think that's going to be a little bit easier to work with here as we're testing things. So let me, again, as I'm reaching up above, for those, you all know, the storage lives behind the camera, so to speak, on some shelving. And so whenever I need to get up and get it, I like to turn the camera off so you don't see the grab some little micro switches, some little tactile switches here, and we'll bust out a little breadboard to put them on. And that'll give us a nice forward and reverse button to work with, which I think this harkens back. Chris, do you remember? Maybe some other folks were here too or have watched in the meantime, but I remember Chris specifically being here for an adventure maybe a couple of years ago where we were playing with some like lensing for the very early Demilight prototypes. Like playing around with like dollar store lenses and flashlight lenses and some of the early ones to try and like see if there's possibility of integrating like a zoom lens into a Demilight form factor. This is essentially going to be that rig again. Just a stepper motor connected to a couple of buttons and an Arduino, which is kind of a cool throwback. So we'll get our breadboard there. Let's just unplug this from power. We'll bring a ground connection over. we'll put in a couple of these little tactile switches. I think they're meant to go like so. Guess I should confirm. So these are a little 4-pin tactile switch, and I can never remember which direction is like they're in 2 pins. It's a single pole, single throw switch. I never remember which direction the pins are paired in. So let me just take my meter here just briefly. Yeah, so the plastic, it's going to be really hard to see. The plastic molding on the bottom here indicates the way that the pins are permanently joined, which is kind of nice. Oops. Just shredded that, but that's all right. We're not going to use that one anyway. So that means I want to have these oriented like so. There's one. There's two. A little sticky uppy from the breadboard, but I think that'll be okay. And we'll just do a little quick hodgepodge wire to these. So that one will be connected to ground, and its other side will be connected to pin, let's say pin 9, and this one will be connected to ground, and the other side will be connected to pin 8. All right, so we'll plug our Arduino back in. We'll write a little bit more code to handle that, and we'll be in business. So I'm just going to wholesale comment out our existing loop function here, and I'll write a new one. So we'll say void loop. Let's see, in our pin modes here, let's see, we'll need a couple of pins to represent our buttons. So we'll define up pin 9 and define down pin 8, the buttons that move the winch up and down. And that's maybe a little bit optimistic of a name, right? Because we're just sort of hoping this all works. We'll say pin mode, up pin output. And by the way, so like I know I'm a fairly recent convert to VS Code for Arduino programming, but this is exactly why it is awesome. So right, I start typing pin mode, and it auto-suggests for me the pin mode function, right? Then I start typing a variable, and it auto-suggests that for me and auto-completes it. It really helps like avoiding the silly typos of, you know, the things you run into when you're working in a not as full-featured IDE. You don't see it does like active color coding, that like also helps you verify that things are working correctly. Anyway, actually this wants to be not an output pin. That wants to be an input with a pull-up on it, as does the up pin. And we will say if digital read up pin equals high, and that's the wrong place for that parentheses. Gosh, I made a mockery of this. If digital read up pin is high, we'll move up. Else if digital read down pin equals, and again, I guess we have a pull-up on these, so these want to be active low. So we'll say if these are low, then do a thing. We want to move down. And to move up and down, we'll basically just reuse our code from down here. Step pin high. I guess I'm not entirely sure. Digital write dir pin. I'm not sure which voltage on the direction pin corresponds to which direction, but that's an easy enough thing for us to find out once we start actually running the darn thing. So in either case, we will set the direction pin to the appropriate voltage, although we might have those backward, and then we will pulse the step pin once with a brief wait. James says, are you providing staging for Lala? Yeah, I don't know if you've heard, Lollapalooza is actually doing a hamster-based act on a 4-foot by 2-foot stage. And so I'm providing a stage line 1. It's a 1-foot stage line with some of the micro truss stuff. No, but that would be a hoot and a half, James. But no, sadly, we're not quite there yet. But we are, in theory, there in terms of uploading some code and seeing if this thing works. So let's zoom back out here, make sure that code actually uploads. Yep. And then in theory, I said in theory. Oh, helps if I turn the power supply. Ah! Helps if you turn the power supply on. Oh, we got one. Oh, we got both. Hey, there we go. So I got an up button and a down button. Let's think about which one of these is which. This, I guess it depends which way we wind this on the spool, frankly. So either of them could be up or down, depending on which way we finally orient things. Yeah, well, that's quite good. Well, I'm going to slow this just because I'm a little bit afraid. I'm going to slow this down just a little bit more by increasing the microseconds between steps. Just so we have a little bit more time to react if something does go wrong. We'll re-upload that one more time. And then our barrel is at 90%? 90%. Okay, so maybe a few more minutes. That'll give us a little bit of time to get this thing finally set up. And clean off the desk a little bit so if things do go catastrophically wrong, maybe they don't, like, you know, catch anything that we're really going to miss as we go. All right, so, yes, nice, slow, gentle movement of the stepper motor as we do these things. All right. Very good. So now, I guess here's an interesting question. So I'm gonna disconnect this from the barrel, from the arbor rather, and we're just gonna move this rig over to sort of center stage. Now, right? Because I busted this, I can't attach this to the arbor at the moment. Ooh, let's put a little keycaps on our tactile switches, make them a little easier to press. But we can certainly try running this mechanism with the stepper motor attached. I'm like quite nervous about this. I'm going to reach over and actually slow this down even further, just because I don't know what's going to happen. But I suppose that's why we're here. Maybe we'll get this nice and framed up so that whatever happens, we can see it. And if it all goes horribly awry, my next of kin can be apprised. So if I were to rotate, yeah, Chris, so I was just going to say, if I were to run this in the clockwise direction, which, let's figure out which one that is. That is the right-hand button. Maybe let's label these real quick, because I'm going to forget. From the perspective of the stepper motor, the button on our right here is clockwise. That's our tightening direction, so that should tighten and then cause the ratchet to click. I don't need a load for that to work. So that's clockwise, and this is going to be anti-clockwise. That's really going to be blown out on the camera there. Oh, there, you can kind of tell what it is. So I've now got this other stepper motor plugged in. If I were to tighten this against the ratchet, I should be able to just see that ratchet clicking, even with no load applied. So let's give it a try. Actually, first, stand by. Thank you, Chris. Yes, I was muted, which is probably good because you could not hear the worry in my voice, only the sounds of chill music. No, I was just saying I don't think there's much of a chance that this is actually going to catch on fire. I do think that there's a decent chance that it flies apart into some tiny pieces. So we'll just have to play that as it goes. So I'm gonna actually take my headphones off because those just play the tasteful music in my ears. And so I can hear what's happening here. I'm gonna hold these parts together with my hands because this is gonna want to torque up and off the table immediately. And we'll just see what happens. I'm just gonna hold that there. Oop. Well, I don't have enough strength to overcome that ratchet. At least not on this microstepping mode. Let's, I don't know if I get more torque with a single step mode or not. Wow. But let me pull up the manual for this real quick and we'll figure out how to put ourselves back in full step mode and see if that makes a difference. Let's see here. So this is the DRV8825 module. Yeah, Chris, we're exactly going to do that. We're going to see about putting ourselves back into full step mode. Let's see here. You know what I'll do? I'll take this back off camera and we'll just go into the Amazon listing where I bought this, which I know explained. Like, so what the thing is, I've got these 3 little dip switches here that put it back into micro stepping or full stepping mode, and I can't ever remember what configuration of the switches is supposed to be which. So we'll just go back in my Amazon orders, although you don't get to see my past Amazon orders, and see what it says. DRV8825 breakout dip switches. Let's see here. Micro step size. Okay, so full step is all of them low, and with all of them high in the current configuration, we're at 1/32 of a step. So if we were to take this down to, if we take switch full to 16th of a step, I think if this is low, then this becomes oh, now, funnily enough, this seems like micro-stepping. I don't know if you can hear the change in here. Let me turn the music off for a second. Can you? I don't know how well you can hear the stepper motor through the microphone. But like, listen to the difference in tone between and with all the switches in the alternate position. I think this was in full step mode. I think this has been in full step mode the whole time. Well, that doesn't make a whole lot of sense with our calculated like rate of rotation. But I think that's microstep mode. But that's going nowhere. Well, maybe we can move this position on the ratchet and get things with a little less tension in the ratchet. Maybe things will move better. Here, I might have to... Ah! I might have to rip the ratchet apart. The other thing I could do for testing purposes is like just hold this ratchet with my hands and apply a little squeezing force on it, and that would sort of let us modulate how much force was on this ratchet. Try and get a little poking stick here and get these ratchet pawls back in place. All right, so there's a part of me that just wants to scrap this whole like half clever, you know, the ratchet surrounds the barrel idea and just go back to like a bog standard, like it's an arm on a pivot with a spring, kind of like our first design for these, right? Like where there's nothing really fancy about it, but it did, you know, not do this. Okay. That pole is back together. So, yeah, so here I'll tell you what we'll do is I'm just going to kind of leave my hands here as the spring, then I'll use my other hand to press the button, and we'll hold this with my third hand. Wow. Let's go back to, like, 8th stepping. Is it the pawls at all? Something else binding? Oh, well. Well, at least it rotates. What is happening? Oh, that's annoying. Because we made those modifications last time to these support arms, they're intersecting with the ratchet wheel. They're actually catching this side of, can you see that? This side of the ratchet is catching on this side of the frame. Ooh, but just a little bit. We can do some frame surgery and correct that, I think. Maybe without even taking the whole darn thing apart, although it probably would be smarter to do so. Here, I'll tell you what, let's just undo this. Pull that ratchet wheel off. Of course, I've hidden the chat, so if you've been suggesting smart things. Are you using max volts? Yes-ish. Close. I think I can do some... Well, you know what I could do is some filing. We haven't really done any filing tonight, so maybe it's time for some filing. That other barrel is done, but until we understand what's going on here, I don't really feel like breaking another one of those tonight. I mean, I feel 100% like breaking another one of those tonight. That's probably what's going to happen, but I feel like we should give it the old college try to not, you know. Let's get this all nicely filed down. Let's do the other side as well. Get that all nice and filed. I do love a good file. Okay, let's see. Does this now put our friction washer back in here? We'll put our ratchet back in here. We're still catching. It's fine. I didn't think this changed that much. You know what I might do to cheat it is just push this barrel a little bit deeper into this bearing. That's going to give us a little bit more clearance on those parts. And it shouldn't affect too much else. Right? Why is this fit so much worse than it used to be? This ratchet... Why is this ratchet wheel hole so big? Is that always how it's been? Is this the wrong ratchet wheel? Maybe this is the wrong ratchet wheel. That would explain a lot. Let me get into my big box of ratchet wheels. Did I? Yes, you know what's happening. Here's another thing I can demonstrate. So, I think when we modified this barrel, I goofed up the barrel or ratchet wheel, depending on how you want to look at it. So all of the barrels so far have had this shoulder in here on which the ratchet wheel rides, right? That keeps it centered, right? So this is all dimensioned to fit that shoulder. But look at the newest draft of barrel. Somewhere along the way, I lost that shoulder, and so this ratchet wheel is now slipping down to like hit the rest of the frame where it should be centered on this where it actually clears everything. Well, that's frustrating, especially knowing that we just finished printing another barrel. I guess we could print another ratchet. Yeah, get that printer fired up. I mean, it probably wouldn't take that long, right? And that ratchet part is really simple. Let's see, what happened here? I guess this ratchet doesn't even have that center hole. Well, let's get that ratchet printing. Let's save that as an STL. I can actually show you what we're doing. We're printing new winches. We're saving them as an STL, 52321. That's the new ratchet wheel, the red herring ratchet wheel. We'll bring up Perusa Slicer. No, I don't want updates right now. We have ratchets to print. Pull the ratchet wheel in, and let's do this at high speed, draft quality, PETG, because that's what's loaded right now. That's going to take 10 minutes. Absolutely. Well, plus the time it takes me to set it up just now. But that is fine. Let's pull the new barrel off the bed. Here y'all can enjoy a little over-the-shoulder view. This is the point where if I had the Epoch cam plugged in, we could like take a look at it, you know, showing on the thing, but I don't, so we won't. Sorry for that, what I imagine was a pop of sound. I do apologize. Hopefully y'all can hear me again. Well, to make a long story short, I ripped the audio interface off of my desk in my excitement to get to the 3D printer. So that's exciting. But we will save our new Ratchet wheel, and we'll put that file onto ye olde flash drive, which I think I saved in the wrong folder, as printed, Winch, Ratchet wheel, there we go. Put it on the flash drive, eject the flash drive, take the flash drive, put it in the printer. Time for a short story. Oh, yeah, okay, so I have a story. Here, let's get this bed cleaned off. I have a bunch of stories from this week, actually. We had, hang on. Let me do this in a way that's not going to rip the audio interface off my head again. Hang on. I think y'all can hopefully still hear me. Probably peaking a little bit now. I turned that gain way up. Take some Windex. So I'm using Windex, just plain old Windex, to prep the bed for the PETG prints. And that's because I've not done a ton of science on this, or nor experimentation on my shiny printer. I don't feel like experimenting on the shiny new toy. But the Windex is preferable to isopropyl for PETG prints specifically, because the PETG, at least in my situation on the flexible print beds that Prusa provides, can actually bond a little too strongly. So what you need is not so much like, you need a cleaner is nice, like getting rid of the oils on the bed is always a good thing. But what you really want is a separation agent, so that the PETG actually releases from the print bed successfully. So that's what the Windex provides. That's a thin layer of, a slight chemical buildup that allows you to successfully get the PETG parts off the bed. Anyway, that's the theory. Like I say, I haven't really played around with it, but that's the advice from the internet that I've been following, and it seems to have worked all right. All right, so here is our new barrel. Just crack this off here. There's just a thin layer of supports on the outside here. We'll need to free up. Ah, yes, Chris makes a good point. Yes, so I also flip the sheet steel over, so one side is isopropyl essentially for PLA for me, and the other side is Windex for PETG. Let's do a little tidying here while we're waiting for what happened? All right, so we'll tidy up just a little bit while we're waiting for that to print off. Let's see. Is this still attached to anything? No, of course not. Let's move that out of the way. We'll move this out of the way. So that. Ooh, what's happened here? Oh, my power supply has come unplugged again. It's fine. So that's going to be our test rate of rotation for tonight. Clockwise, anti-clockwise. Let's see. I guess we could start reassembling the new barrel into our equipment. Redo some of that filing that we did earlier. I know everyone was really excited about the filing, so I'm happy to provide. No, the story. Well, let's see. What stories can can I tell from this week? I always feel it's like a little bad baseball to get too deep into like anything about like no one wants to hear about like internal company politics or anything. That's boring and not really my place to tell. But just thinking about like what interesting technical things we came across this week. Here's a real simple one. I'll tell you a story that has nothing to do with any of this. As soon as I get this, this part's not doing anything for us. I could basically just rip this off. Hi, Kenneth. Kenneth's found the filing kind of abrasive. You're killing me, Smalls. Let's see if we can't. There we go. Get this bearing off of here. Let's see. Oh, so here's an interesting tip for a very niche audience, which is ran across an interesting phenomenon earlier this week, which will be obvious to some of you and maybe not obvious to some others of you. So we are finalizing the installation of various control parts into this airplane automation system that we have at the museum that I work at, that I've been working on for the past several months now. And one of as part of sort of the finishing extra touches to this control system, which essentially is a PC running a tkinter Python program that allows for like automation sequencing of some basic aspects of the pneumatic actuators on the plane. And by basic control, like it is basically just sending serial commands out of a serial port, which then get ported over RS-485 to a matching receiver at the plane, and that's responsible for like turning those serial commands into actual like control intent for the surfaces. Also, all of the mechanics are electrically interlocked in relay logic, right? So the controller actually isn't doing any of that, but like things like you can't put the main landing gear down if the main landing gear door is closed, because there's a pair of physical limit switches that only allow that wheel to move down if that door is fully open, things like that. So there's nothing that I could do in my controller would actually cause like mechanical things to run into each other, which is very comforting for a software developer, novice like myself. But one of the things I was adding to the end of this project was a couple of like utility features in the control room next to the computer, like a nice toggle switch, a little beep, doop, toggle switch, rotary switch on the rack where the computer is that just applies and removes power to that RS-485 converter. Just so it's really easy, like if you're working on the computer and you're like, I want to do some stuff and test out some programs, but I don't want there to be any way for signals to get from the computer to the actual plane. You turn the switch off, and then the converter is powered down, so no signals getting out no matter what you do, right? Sort of an administrative constraint. Like it's not a lockout system, it's not a safety system, it's just a convenience feature. So there's a toggle switch, there's a power light indicator, there's an RS-485 signal indicator, which is just a little RS-485 transceiver board. There's a story there too. We're at 38% on that print, so I got 62% more of a story to tell. The indicator pack that I had, the indicators we had purchased, ran at, they're, I think, 12-volt indicators, and the power supply for this RS-485 converter is a 5-volt power supply, I think. I'm mixing up the voltage here. Suffice to say, like they were not the same voltage, and so there would need to be some voltage level conversion. One thing that we have a bunch of in storage at the museum for all kinds of purposes is solid state. When we have lots and lots of relays of all stripes, we have a lot of solid state relays kicking around from a couple of previous projects. And I was like, well, that's great. Solid state relay takes a DC voltage between 3 and say 32 volts DC, and controls a circuit, like allows current to pass or not. Great. But I had to go down a little bit of a rabbit hole, and this is where the story is. And listen, you asked for a story, Dave. This is what we're getting into. Many, it turns out, relays are specifically AC relays in that they're triac controlled. And as we all know, the wonderful thing about triacs is triacs are wonderful things, is that they only turn off, of course, when there is a cessation of current, when current goes to 0. That's the whole point of a triacs function. You turn it on with an impulse of voltage on the control side, and it only opens when the voltage drops to 0 across the load. And that's, of course, not what we want. We also have a bunch of DC solid state relays, right? So those, that's ultimately what I ended up using. But there's also this whole class of like back-to-back dual MOSFET AC and DC switchable DC relays, which I'm still not 100% clear on how that works. But yeah, long story short, don't use a triac to switch DC, I guess is the point of the point of the thing. It's a little bit wobbly now, which I don't love. I'm not entirely sure why. Yeah, that's basically the story. And then, so I had, yes, yeah, not triacs. We ended up, I was beating my head over, and you're gonna laugh at me about this. I was beating my head over, we have a power indicator for the RS-485 converter. We have a power switch for it. We also have a power switch that supplies and removes power from, there is an RF remote control that's mounted outside the control room that allows volunteer coordinators or pilots to trigger the automation so automatically and advance through it at a given rate if they want to. And they, so we have a power switch there for that RF converter, so we can remove the ability to remotely control it if we ever want to. Especially, frankly, a lot of this is just for me, right? I want to be like, I'm going to work on this program now. I don't want somebody to wander by and click it and throw off whatever I think I'm observing, right? Selfishly. So we have a power switch for that. We have a power indicator for that. We have a signal level indicator for that, which is great, because that's a 12, that floats high to, I think, 12 volts and then gets pulled to ground when you activate the relay. It's easy to put on the indicator. But I was kind of beating my head, and again, this is the part where you're going to laugh, about how do I do, what I wanted was a signal indicator for the RS-485 link between the control room and the plane. And I didn't want it to be a software thing, and I didn't want it to be on the RS-232, the serial side of things. I wanted this to be like, is there something that looks like an RS-485 voltage present, a non-marking voltage on the RS-485 pairs? And I was like, wow, we're gonna put we're gonna put like an op amp on there that's gonna compare voltages. It's not gonna be too high of load, but a unit load in RS-485 is like a 15 kilo ohm equivalent load. It took me 2 days to realize that the answer is just to put an RS-485 receiver on the line. That's what they're meant to do. They're meant to see whether there's signals on an RS-485 communication line. So I took a little tiny module that I had lying around from all these stupid projects, and I whacked it on the line, and I put a level converter on that, and I put it on the indicator, and the problem was solved. But I couldn't, I was like, well, okay, so if they're normally marking, the voltage difference between them will be like 6 volts in this direction, but if they're inverted, I want the light to light up. Just use a Max 485 chip. There's chips to do all these things now, so you might as well use them. Was that a short enough story? We're not even at 70% of this print. I feel like I've really lost my edge here. In any case. Optocouplers are a life for level conversion? Yeah, for sure. Well, so it's funny. I've been clearing out some of the old engineering offices, and this is now just story time. As we've been clearing out some of the old engineering offices, we can kind of get a sense of like what the flavors of electrical engineering that were required at different stages of the museum were like. Partly because there are a ton of optocouplers and triac drivers and triacs in the various old engineering storage offices. In fact, how much time have I got? We're at 74%. There's a fascinating part that we found. Do I have one here at home? Are they all at work? Give me 30 seconds to see if I have one of these things. It's related to this story. It's cool. If it's not, I'll come back and I don't know. We'll show you something else cool. Here, stand by just 1 second. Well, it wasn't in the one place I thought it would be. It might be in this other place, but I mean, if I were to turn the camera back on now, you would. I mean, like it's fully the full belly button experience for you. Which, I mean, listen, if that's your thing, that's no judgment, but it's not what I'm trying to put out onto the internet these days. No, I'm actually, if I was very clever, I stashed it in my bin of opto ISOs, which would be an odd place for a 40-year-old device that I'm never going to use. But I'm just thinking maybe in a fit of cleaning, maybe I stuck it not in the interesting things for the future bin. That's all fine. But in a more logical place for a change. But I don't know. It doesn't look like I did. That's killer. Okay. Well, good. Well, this is just teasers for next time then. I'll tell you about what it was anyway, because I feel like that's just cruel. While I think of where else it might be. So what it is a thermal isolator. It's not an opto isolator, it's a thermal isolator. So it's a little metallic package. It kind of looks like an old crystal filter package with 5 pins, 4 pins, six pins. In any case, it's basically a power resistor internally. So you apply your control voltage across a pair of pins. It heats up a, I'm going to get the direction wrong, but a heat-sensitive resistor. I can't, positive tempco or negative tempco. Must be negative tempco, because as it heats up, the resistance drops and allows current to pass through the load side of this isolator. So what an opto isolator is to life, this thermal isolator component is with heat. Fascinating. We have half a dozen of them in this old box in the museum, and I'm kicking myself because I'm almost positive I brought one home because I was like, this is freaking cool. But I, of course, don't know where it is right now because I didn't expect to be telling a story about that tonight. What I did expect to be doing was testing the winch with our freshly printed Ratchet wheel. So that story timed out just right. Ooh, this is hot. It's real hot. I forget PTG prints with a really high bed temperature on these Prusa Minis. Will you come off the bed though? Maybe I'll let it cool for a second and then we can take it off the bed. I was trying to find there's a company name printed on it. That's the tummy you were missing earlier. And the internet seemed not to know very much about these parts. They're of a very specific age, presumably before semiconductors. Oh, sorry. Enrico, stand by and go. Just to be clear, Enrico, whatever you do, I'm not liable for whatever you took a GO on. But thank you for clarifying the standby. I really do appreciate it. My stage manager wife would be just so proud, or ashamed, one or the other. All right, let's get this off the bed here. Thank you, Enrico. All right, let's stick that heat bed back up there for now. And let's see how our fit is here. Little bit snug, as it always is, so you're in luck. If you missed the filing earlier and we're sad about it, we're going to do some more filing. Make that a little bit looser. All right. We'll probably lubricate this as well, because this should be a nice slide fit on our... Ooh, it's a little tight. A nice slide fit on that barrel shoulder there. Get that nice and sanded out. Thomas is sitting. Kenneth was lying down and had to stand up. Listen, I don't make the rules. I mean, I guess in a sort of literal way, I make the rules. But other than that, I don't make the rules. You know, when you gotta stand by, you gotta stand by. Ooh, it's a little tight. It's a little tight. Yeah, something's gone screwy in the remodeling of this barrel. Because this is clearly not the design we had been working with. Wonder. Yeah, in fact, even this redesign doesn't have that shoulder, which is interesting. Enrico says, spent many hours of my life sitting while standing. Yeah, I hear that. My days as a board op are behind me, but I still do a handful of programming from time to time. I did have to troubleshoot an issue on an Ion RPU the other day. I wrote processing unit for an ETC Ion, running 2.0.1 firmware, which was kind of a trip. Like none of the shortcuts and hotkeys that I am familiar with worked. It was a time. Back when the on-screen keyboard was looked like it was like GUI interface buttons as opposed to an actual keyboard. Well, it was a mess. No multiple frames per display. Thomas says Geo is in storage. Yeah, well, then Thomas, you're just going to be in a long standby. You know, that's I can't take responsibility for whether you're ready to take those cues or not. But you know, next time I hope you'll have that at the ready. All right, well, that's a decent fit. Maybe we'll do just a little more sanding. But I really don't want to break this barrel that we just spent, you know, another 2 hours printing. Something messed up, time to start over. This would then be the third time I think we've started over on this winch design, which is all really just, you know, curiosity and procrastination to not deal with the like mess that would be ordering new Demilight boards right now, because just the world of electronics parts has crumbled into chaos in the past few months. Yeah, Enrico, you actually might have had a better time on this this RPU that I was working on the other day. But yeah, the new ones, this was, you know, an Ion RPU. The new ones, the XE, I've only had to touch a couple of times. Just not to get totally inside baseball on the lighting console feelings, but I think that the XE is a real misstep in that they took away the LCD screen on the above the encoders, right? Which I thought was like the best part of an Ion, say over an Element, is you could look at the encoders and be like, what are these displaying right now? Like you could on a Geo or an EOS, and they took that away. They made them on-screen elements only, like only on your computer screen. And so I think it's a lot harder to use. So if anyone from EGC is watching, well, first of all, if you wanted to sponsor me, that would be cool. But also, bring back the LCD screen. It's a great feature. Okay, well, that's better. That, like, actually centers and spins without hitting everything. Jeepers. Okay, well, let's get this off of here without breaking it. And see about putting our friction washers back in. You know, seeing how snug this is, I'm tempted. And I know this is just playing to the crowd, but I think a little bit more filing is in order on this. Listen, Thomas, you're totally right. The XE is a fine console, right? The whole EOS, Geo, Ion Element line is a fine idea. It's miles above the, you know, the expression line that we used for so many years. Like it is all good. However, I pitched, yeah, Chris, I don't know about back on track. I think that I would much rather, knowing that they, of course, now you can't really get new firmware on them, but I would much rather have programmed an old Ion than on an XE, for sure, just because of that screen. All right, let's get this ratchet wheel back in place. So this is going to go like so. Yeah, okay, let's get those ratcheting pawls back in place again. I know we haven't had to... Oh, that was so easy. Woo. Oh, all right. My lucky day. Okay, we'll put the big friction wheel there so this doesn't have to screw in too far. Ooh, that is toasty. And then we will screw our barrel. Let's get that ratchet wheel really set down on that shoulder. If we're going to reprint the ratchet wheel so that it fits that shoulder, we're going to get that ratchet wheel sitting on that shoulder. Gosh darn it. And then we will... Why isn't this not... threading in. I flung those pawls to infinity, but I think it's worth it just to make sure that this really does thread nicely. Ooh, Dave had one of the original concepts. Dave, that's before my time, but that's a very cool bona fides. for sure. Let's see. Thomas's school has a Hog 4 engineering model. Ooh. But no touchscreens. Oh, well, what's the point then? I feel like that Hog 4 just like is a collection. Is just touchscreens. That's the whole point of the thing, maybe. Yeah, Enrico. Dave kind of holds down the fort for us on the some of the finer pieces of history in lighting things, which is awesome. That's not shade in any way. That is really, really very cool. Oh, that is ripping hot. Maybe I should turn the voltage down on that stepper a little bit. I mean, the power supply is currently off, and you can take bets whether I'll remember to turn it back on. But let's see here. It's awfully hard to thread blind. Express with emphasis, says Cookie. Yeah, classic, a real classic. Yeah, my first console that I ever operated was I don't even know, a nameless 2-scene preset without dipless crossfade that I ran for a production of The Lion, the Witch, and the Wardrobe when I was 10 years old. And the rest, as they say, is history. Or maybe they don't say that, but yeah, it's been a lot of years. I think in our high school had a Strand 200 at the time, which was not great even then. But it, we only had like 25 lights, so it got us through. And then in college, we spent a good while with the Express and one of the early Ion Classics. Were our primary consoles there, with a couple of those by the time I graduated, thanks to a couple of well-written funding proposals that I had a very minor part in that I'm still proud of. Thank you very much. Including when we wrote the funding proposal to buy the new Ion, for the one of the earliest Ions, the student funding committee we were like, well, we want an Ion, which is a $5,000 board at the time, and we would like a couple of monitors and a nice carrying case for it, so like a Pelican case doesn't get broken, and a keyboard and a mouse. And they were like, ooh, that's a $6,400 package. Ooh, that's a lot. What if we bought you the $5,000 board and you guys buy the accessories? And we're like, well, you drive a hard bargain. But yeah, we can come up with $1,400 between 100 student groups. So yeah, that's how we paid $1,400 to have the student government buy us an Ion, which is pretty great. Okay, so that is finally assembled. I don't know what we're going to be looking at in terms of spring strength needs here, so I am going to, once again, sort of try and do this slightly by hand. Let's see. Motor power supply is back on. Take that, Kenneth. And... oh, helps it... so the power supply is on, but you might have noticed that I forgot to plug the stepper motor itself back into the driver. All right, so let's put ourselves back in the smallest stepping mode, I think. Is that. Let's find out. Ooh, hello. That stepper just like turned itself all the way over. All right, let's hold that down again. And... hey! So now what we'd want to see is when the ratchet engages, what should be happening. So the ratchet is engaged, so this should be fighting, so it should be loosening itself on the... like this tension wheel should be loosening itself, and it's not, which is concerning. Oops. Oh, there we go. We're just a little bit stuck there. So we tighten up, and we move against the ratchet, and then with a load applied, oops, and a button in place, it loosens up, and then this would tighten it up again. Hey, that's success! So more work to be done on the ratchet, and figuring out what it would be. I mean, I think this mechanism is very clever, and I'm very proud of it, but I think it's maybe not the right one for purpose. And what I really wish it had was a better way to adjust the tension on the ratchet. Because right now, that seems to be a very finicky part of this design. But the fact that it does the thing, it loosens and tightens. No, Chris, I think this is in half-stepping mode. So I guess technically, yes, it's in micro-stepping mode, but not anywhere near, like, full 30 seconds of a step. So let's zoom, whoa, back out and get our test arbor back in place, which has been sort of dangling here with, you'll recall, hanging off of this wire, a load, which is a pair of vice grips, hanging off the table this entire time. Let's get this thing hooked back up, and I'll see if I can do it without breaking anything this time. I do think we do need to do just a little. I know, don't get too excited. A little bit more filing. Get a little bit more clearance on the interior of this slot-shaped hole. Dave says for the tension, I assume, for really tiny turnbuckles. That would be adorable. I feel like we'd be... I mean, we're already clearly past the limits of my mechanical ability on this project. I feel like turnbuckles is just asking for, like, disaster. There we go. All right, so that's in not super far into that coupler, but in, I hope, far enough for testing purposes. We will once again apply the sticky tack of science. Yeah, Dave, I know. I thought about sending you a telegram saying, like, hey, Dave, it's filing night. Make sure you attend. But I wasn't sure if you had a previous engagement. Telegram is not meant to be a dig, by the way. That's just the humorous method of communication that came into my brain. Okay, so let's see here. So if this had been wound up some already, it would have rotated in this. I want to make sure we're really are applying a genuine load to this thing in a way it's going to be meaningful. So I'm actually going to adjust. I know you can't see down off the camera here where the load is. Carrier pigeon, yeah, exactly. So I'm going to sort of pre-wind this as if it had already been, wound up some to put some tension in this wire, and then I'm going to engage the ratchet manually. So this is holding itself on ratchet power. The power supply for the stepper itself is actually off, because that's the whole. I haven't said this tonight, I think, enough, but that's the whole point of this design is we don't need any power anywhere in the system for this to be statically stable while a load is applied, right? And then when we apply power to the stepper motor, we are merely using that to lift or lower it, but it is stable with static off. Okay. So, stepper power supply on. Let's try lifting first. And I'm going to sort of, again, be the spring here. So that when it stops moving, I guess we'll see if we have enough torque to lift anything to begin with. And maybe I'm sure that the motion of this wire will not be particularly visible on camera. So just for argument's sake, I'm going to put a little piece of blue tape just there. I'm going to put a little piece of blue tape on the shaft here so we can see it rotating. And maybe we'll just frame ourselves up a little bit better here if we can. My fat head there is in the way. Let's tip up a little bit there. Yeah, wow, that didn't really make it much better, did it? Here, sorry for those who get motion affected. We'll just do a little camera work as we continue to stall because I'm worried that this thing is gonna collapse in our arms after such amount of work. But I think there's nothing else to it but to just try it, right? That's the whole point. Let's get this as aligned as it can be. Some torque on the system here. All right, here it goes. Oh. Oh. All right, so up, something is binding is what's happening here. It's something is like or there's a loose connection or something, because up is only working very intermittently, like only moving. Maybe there's a loose connection just on the breadboard here, but up is working fairly well. Now the ratchet is not engaged at the moment, and it's still holding solid, which gives me a little bit of cause for concern. Because I don't know what component is taking that stress at the moment. But it does buy me a second to fix the ratchet. Here, let us... I think this will be more interesting a little bit more zoomed in. Let me see if that's possible, even at a wonky angle. What I really should have done is set this up farther upstage. But in fact, that's the thing we can do. The power of sticky tack, we can just move the whole assembly further up. All right, sticky tack. And see, this is my mean. Like, the ratchet is entirely non-present. And so is it just the holding force of the stepper motor that's holding this in place? What I think I'm going to do to test that theory, which I suspect is what's happening, is reinsert the ratchet and then turn the stepper motor power off and see what happens. And if it suddenly wants to start plummeting, we'll know that it was the stepper motor holding it in place this whole time. So you're going to see a lovely view of my hairline, which is great as I get in real close to see. There we go. I'll get that out of the way. Okay, so now let me turn the stepper power off. Yeah, I could feel that settle back down onto the ratchet. That's fascinating. If I were to remove this ratchet, would this fall? No. So something in the system, some friction, is causing this not to lower on its own. Bearings probably need more sand. Yeah, could do a little bit more filing. We can see your camera bar stools. Chris, I don't quite understand. Maybe I missed something. Let's see here. Well, let me get that ratchet re-engaged. I'm a little bit perturbed as to like the fact. I mean, there's not like a lot of force pulling on the load. Like, it is just a pair of vice grips, so it's maybe 10 ounces. But I would have thought, and maybe there's more sort of like consistent friction in the stepper motor than I would figure. But I'm just a little bit weirded out that it's not wanting to move at all. If the problem is it needs more weights, like, that's an easy solve. But if the problem is that there's like something binding in the system that I don't know about, that's a bigger problem. Okay, well, that's the ratchet re-engaged at least. Let's turn our stepper power back on. Check the value on resistors. They are too high. Yeah, oh, I see. Yes, I have too much resistance. I get it. All right, so let's see here. So part of the issue is, I don't know if you can tell, like, this frame really wants to torque as this thing moves. And that's applying quite a bit of side friction onto everything. Now, will it lower? Well, it certainly lowers, but again, I think it's mostly just lowering because the stepper motor is turning, right? Like, that ratchet isn't even engaged. Let's get this. Oh, well, now I've been just entirely. So that's an interesting data point. I've entirely unscrewed the stepper motor from the thing, and the weight isn't falling. If I remove the ratchet, oh, it's slowly starting to move. But I think a huge part of what's happening here is the frame getting twisted out of alignment, and causing a lot of friction on this bearing. So I think one thing that will need to happen following this test is building a stouter frame, perhaps with an upper member. I mean, this is unwinding. Like, that's a good sign. I guess. Like, the laws of physics do still apply to some degree, which is good. I was a little worried there for a second. Again, I apologize that you are really getting the up close and personal experience at the top of my head, but that's just what it's going to be. All right, let's get this threaded back in. I also think I need to do some work to make there be like this threaded part here is just not like a nice enough like fit to like when I run it in reverse, it should unscrew itself enough to cause the winching action. And we know in theory that this works because we've done this on our hand winches before, but like that has now unscrewed itself a little bit, but this still isn't falling, which is bad. Like this should be tightening on itself. And so somewhere there's just a bunch of friction in this system. Maybe more weight is the answer. All right, how about a water bottle's worth of weight? What could go wrong? We'll just we'll thread the vice grips through the handle of the water bottle. And we'll use that to clamp onto the wire. Oops. Like I said, we'll use that to clamp tightly onto the wire. There we go. Now that's a load. Okay. Will we lift it? Well, yeah, as you can tell, shaft is spinning, bobbin not spinning. Bobbin run loose on shaft, line not move. Oh, bobbin go down. Oh, so that's cool. So that's actually doing the winch motion that it's supposed to be doing, right? With the ratchet was, oh no, the ratchet's not engaged. Well, nah. So you can see, it's loosening. It is loosening and tightening there. If I just run the stepper back and forth, you can see just sort of above my head here on the camera, right? It is loosening and tightening on those threads, which is what it's supposed to do. And then it gets to that ratcheting section, and the ratchet starts to move, which is good. It's just that this is now slipping on the shaft here. And then if I engage the ratchet and I loosen, this starts to loosen itself, which is good. But then when that happens, in theory, the torque on this shaft should begin pulling this looser, and that's also not happening. Let's pull this. And of course, the whole thing is being held to my table by sticky putty, and so like it's rapidly coming out of plumb. But like it does do the thing. It does loosen and tighten under tension, and that winching action over here is working. It's just that this isn't in any way attached to the shaft in any meaningful way. That's what that hole is in theory for. I feel like drilling a hole into a stainless steel rod on camera is not going to be particularly entertaining, nor particularly quiet. Okay, let's recap. Things that need to be made better. And chime in here, because I'm sure there's badness that I've missed. This frame needs to be more rigid, right? Because it's getting torqued all over the place by this motor being right here. That's in theory what this extra bearing block was supposed to help with, and I think it is. But I think an additional like cross member here would help. And also, frankly, so this is meant to be mounted. I'm going to take the water bottle off of this just now, because that seems like a recipe for disaster. Oh, God. There we go. Okay. So, right, this is meant to be mounted by a couple of points here on a piece of 44mm truss. And if those were held rigidly apart, that might help with the torquing some. I do think an additional cross member here is probably going to be necessary. What else? Obviously, the bobbins, the thread bobbins need to actually be attached to this shaft in some meaningful way so they don't just slip. That's a given. Honestly, this whole thing would probably be improved if I were to set it up on a piece of truss. That we could do. I mean, it doesn't really solve the this is not attached to the shaft issue for tonight. But that's a thing we could do at some point. Let's see, what else? This ratchet mechanism, like, I'm so proud of it, but I think I have to kill my babies here. Like, I think going back to, let me pull out the earlier prototype. So this was the, I think, the final prototype of the hand winch version, obviously minus the errant ratchet wheel. Right, there's our... This is the shouldered version of this arbor that that this is supposed to be mounted on, right? And the reason we went to the, like, kind of stupid complex version that there is now is just to eliminate some of this additional vertical area that this ratchet takes up. But I imagine there's something like this mechanism that would be more compact than this, right? Let's see. Chris says, seems like the threading on the purple piece a tad longer would be helpful. Seems like you're at the limit of the rubber you're using. Yeah, that is true. Or shorter, right? I could have the threading be shorter and use a smaller gasket. Because this has this thrust fulcrum, or whatever we're calling it, has lots of room to come in. Lots of room to come in closer to this. So that could be shrunk down some. Rethink the ratchet, test out the dimensioning on the hanging mechanism on these hanging points here, and then actually fix the bobbins to a thing. But I think we're in a decent spot. Like, if there was, I mean, even if it was just like a little, like, honestly, maybe I'm being too precious about the size of this. I was so proud of how small it was. But maybe, you know, honestly, if there was an arm hanging out here that was the ratchet mechanism, that's not like it makes it radically larger. And the nice thing about having a nice long ratchet arm is even if you're, you know, I guess two things. If you have a long ratchet arm and a long spring, by having a long spring, you decrease the percentage of the spring's total extension that each click of the ratchet wheel is, right? So, right, your spring force is roughly proportional to your length, to your amount of stretch, I guess. It's been too many years since I've taken physics to know what that actual term is, right? But the amount of force that's being applied to this point when the ratchet is here versus when it's here is very different. So it's all a very consistent amount of force. And then by having a longer lever arm, right, we are ensuring that there is a lot of force in this lever causing it to want to move in, but there's not a lot of force here on the ratchet. So the ratchet is relatively easy to turn, and the force is relatively consistent because we have this nice long spring that's only stretching, you know, a few % of its total length. So maybe I need to just scrap this, you know, admittedly incredibly clever idea about these, you know, dual nesting ratchet arms. And go back to a more traditional ratchet arm mechanism. I mean, this just, honestly, this just feels better as well. Like, this is also a quite satisfying mechanism. Ratchet, rigidity of frame, maybe an additional support here, mounted on a truss, get the bobbin set, and I think we'll be in business. And I think that's where we will pick up next time. We're going to wrap it up for the night. No stream next weekend. Have some social engagements, which is the thing that we're just starting to be able to process the idea of having now, which is wild, but I'm very excited about. So I will see you in 2 weeks on, what is that, Sunday, not the 30th, but the 5th? Is it the 5th of June? The 6th of June at 7 p.m. here on this here YouTube channel. If you liked this and you saw it, or you liked it and you didn't saw it somehow, hit subscribe and like, and you'll do all the YouTube-y things. You know how, this is how you know how it goes. Oh, maybe turn on the music next time? Yeah, that's fair, Dave. I'll do that right now. That's my treat to you. Yeah, if you didn't like it, also subscribe. I don't really care. Find me if you have questions or concerns or things, leave a comment on the video, or find me on Twitter at JeffersGlass. If you're like, hey, I have this DMX thing going on. What should I do? Always happy to take questions. It happens more than you would think. Conversations about pixel tape and DMX and all kinds of fun things. I love it. I'm a huge nerd, and so are all of you good nerds out there. Thank you so much for joining us this week. Yeah, this has been great. I love the rabbit hole of like old lighting consoles that we ended up down. Yeah, you're a bunch of beautiful nerds. Be well, wash your hands, stay safe out there, and I will see you in a couple weeks. Have a good night.